Welcome all for the video tutorial on machine learning, and today we will be continuing with the fourth module, that is Bayesian learning. And the fourth module will be seeing the fourth session, that is ML for predicting probabilities. See, what is ML for predicting probability? It is nothing but maximum likelihood hypothesis for predicting the probability. How do you obtain this? Generally, we have an non-deterministic probability. That is, whenever we have a function, the outcome of that function will be either 0 or 1 when we represent that in the discrete output value. For example, when I am tossing a coin, what is the probability of occurrence of either head or tail? Okay, the probability will be 1 by 2. Out of 2 events, the probability of occurrence of one event will be 1 by 2. Okay, so we generally represent that generally we represent that to a non-deterministic function f as x of 0 comma 1. Either 0 will have, we have two events here, and either we will have 0 or 1. Okay, this is the general expression to represent a non-deterministic probability. But here we need only the maximum likelihood hypothesis. What is maximum likelihood hypothesis? Here I want to achieve only the maximum expected, that is likelihood hypothesis here. So what I do, for example, when I am tossing a coin, okay, when I am tossing a coin, take for 10, say for 10 times, I need the outcome to be head. Okay, that is my likelihood condition. Okay, here what is the event? Tossing of coin is my event, and I expect the output to be head. Expecting the output to be head is my likelihood hypothesis. Okay, and what is maximum likelihood hypothesis there? See, among the number of events, okay, number of cases amongst here, for example, if I have tossed the coin for 10 times, among this 10 time, what is the number of time I get the output as the head? That is my maximum likelihood hypothesis. So I am going to implement this scenario. How do I implement? So generally we have the equation as f of x tends to 0 comma 1, but since I need only the maximum likelihood condition, I modify my condition to f of x to be 1. Okay, rather than being f of x of both 0 and 1, I need to have my probabilistic function as f of x to be 1 alone. How do we make this to happen? Okay, how do we make this make f of x to be 1 alone? For that, we are going with that training a neural network. Okay, we do this with using a neural network. We use a brute force way to train it. Okay, what is actually brute force way? What do we do there? We are going to collect all the observed frequencies of 1s and 0. Okay, for the given example, what I have said, when I am tossing a coin, I am going to observe the frequency of occurrence of head, and I am going to collect the frequencies of occurrence of the tail. Similarly, here I am going to collect the frequencies of both 1s and 0, which is both the true condition and false condition for the possible value of x. For the given value of x, what are all the possibilities, what are all the frequencies I have for the occurrence of true condition, I collected, and I collect even the frequency of occurrence of false condition, that is true, that is 0, and I train my neural network according to the frequency what I have observed. Okay, for example, if the frequency is more with tail, I train the machine to have the target function as an tail. If my output, the frequency of occurrence of head is more, I train my machine to have the outcome as head. Okay, so what I do here, what is the way of implementing a maximum likelihood hypothesis using probability concept? We are going to analyze the frequency of occurrence of possibilities, and with that, with the observed outcome, we are going to train our neural network. This is the concept we have in the maximum likelihood hypothesis. We are going to implement the probability concept. Here we are going to use the brute force concept for making the maximum likelihood hypothesis to occur. Usually we have f of function f which belongs to both 0 and 1. Here, instead of having both the cases 0 and 1, we are going to stick only to the condition 1 so that your likelihood hypothesis exists. Okay, and to make that, we train the machine. Okay, we train the neural network. We implement this through the neural network, and we train the neural network by observing the frequencies of occurrence of the events. The formula for predicting the maximum likelihood hypothesis using probability is, okay, we will be using both xi and di as a random variables, and we choose this as a training example, and we are going to draw a sample from that. So we write that as probability of d given h. Okay, and how do you implement the likelihood function here? Probability of d given h is equal to and the summation of I is equal to 1 to m probability of xi to the di given the h. Okay, then when you apply the Bayes theorem, you derive the equation as probability of d of probability of di given hi xi p of xi. Okay, when you equate it, either you will be equating it to the 0 or 1. Okay, so you will be observing the frequencies of occurrence of data. With that frequencies, you will be determining the conditions for occurrence of 0 and 1. And again you rewrite and you manipulate the equation to derive the maximum likelihood condition. So the probability of di given h of xi will be h of xi. You can rewrite the equation as follows: h of xi to the di multiplied by 1 minus h of xi the whole power 1 minus di. Okay, now we are going to substitute the above equation with the derived output. So when you substitute, you will get probability of d given h will be with the lower limit of 1 to m of hypothesis of xi to the power of di into 1 minus h of xi to whole power of 1 minus di into the probability of xi. Okay, so when you write this in the form of maximum likelihood, you derive maximum likelihood hypothesis. The final expression what we derive is argument max of h belongs to capital H with the probability distribution of h of xi the whole power di multiplied with 1 minus h of xi of 1 minus di into the probability of xi. And to derive the we use the gradient search for training your network. So when your machine has to be trained with the possibilities of occurrence of event, sequences of occurrence of a particular event, when it is observing the frequencies, we use gradient search to implement the maximum likelihood condition. Okay, so what we have seen here, how do we implement maximum likelihood condition using the probability concept? What we do here, we are going to make the condition, the general condition of the function of 0 comma 1. What is it? The function may have the output as 0 or 1. Okay, this is the general equation, but we are going to convert that into f of 1. That is, we have only the likelihood hypothesis. We are going to derive only the likelihood hypothesis. How do we derive? We derive it by training your machine. Okay, you are going to train your machine with the frequencies observed. With the observed frequencies, it can detect the likelihood condition. So the machine gets trained with the observed frequency, and finally it will be capable of learning the maximum likelihood condition. With this, your maximum likelihood condition, the max ML for using probability concept is over. Thank you all.